In this video, we'll be solving a question involving a book pushed on the wall, and the question says, a book of mass M is positioned against a vertical wall. The coefficient of the friction between the book and the wall is mu. You wish to keep the book from falling by pushing on it with a force F applied at an angle theta to the horizontal. Then you have the condition for the angle theta as shown in this, and for a given theta, what is the minimum F required, the minimum force required, and what is the limiting value for which there exists a force which will keep the book up. So we are given two things to determine. The first one will be the force required, and the second one is the limiting value. Okay, let's repeat the diagram, and we'll try to place the forces where it should be. We have this to be the mass, and this there is a force existing at an angle theta. So we have for the find this angle, the force is along this. The reaction will be in this direction. Here is normal, and our frictional force will be pointing upwards, which is the frictional force. Okay, let's try to resolve this along both the vertical and horizontal components, and this will be equal to this line will be equal to F sine theta, F sine theta, and for the horizontal components, we'll be having this to be F cos theta. Okay, let's solve this. For the x component, we'll be having n to be equal to F cos theta, and for the y component, we'll be having this expression as well, F sine theta pointing upward, F sine theta, and there is a frictional force as well pointing upward, frictional force, and the mass, the weight will be trying to slide down, which is mg. Minus mg is equal to 0, and we have that the frictional force is equal to mu, the static friction, mu n, and this is equal to mu s F cos theta. If we substitute back to the expression, we'll be having this F sine theta plus mu s cos theta is equal to mg. So let's solve for f. I omitted f here. This should be mu f cos theta. So, and making f the subject formula, sine theta plus mu s cos theta is equal to mg. So the force will be equal to mg divided by sine theta plus mu s cos theta. So, but the second part of the question, we're asked to find what is the limiting value for which there exists a force. For the force to exist, we have that the denominator, which is sine theta plus, okay, that's the b part, the limiting value, sine theta plus mu s cos theta must be greater than or equal to 0. That's the only condition for this force to exist, greater than or equal. Must be greater than 0, not equal to 0. It must be greater than 0. So solving for mu s, then we have this. Solving for mu s, we have that mu s cos theta is greater than minus sine theta, and mu s will be equal to minus sine theta divided by cos theta. So mu s will be greater than minus tan theta. So this is the limiting value at the point where the force exists.